Okay, we're going to answer question number 4. We have y triple prime minus y prime equals e to the x, so our j of x is going to be e to the x. Our differential equation in its homogeneous form is y triple prime minus y prime equals 0. So we're going to call the operator form of this differential equation g of d for convenience later on. And solving for the constant solution to this differential equation will be using the method we used in the previous problem. So the roots of this polynomial, we're going to factor it out. We find that it is factored into d times d minus 1 times d plus 1. So our roots are d equals 0, 1, or negative 1. So our corresponding fundamental set of solutions is 1, e to the x, and e to the negative x. That tells us that our yc, the constant solution to this, is c1 plus c2 e to the x plus c3 e to the negative x. Our next step is going to be finding the annihilator of j of x and calling it f of d for convenience shortly. We're going to multiply it with g of d, and the roots correspond to the elements of fs and h, our fundamental set of solutions to the non-homogeneous version of this differential equation. So the annihilator of e to the x is d minus 1. So f of d times, quote unquote, times g of d is d minus 1 squared times d plus 1. So our fs and h is 1 e to the x e to the x because of the fact that d minus 1 is squared, and then e to the negative x. Now we're going to subtract fsh from fsnh, and the elements of this new set correspond to the components of our particular solution. When we're writing yp, we're going to use alpha to denote a non-arbitrary constant, just to be very clear that we're doing something different from what we were doing in this previous step up here. We actually are going to solve for this constant shortly, you'll see. So fsnh minus fsh leaves us with x e to the x. Our yp is then alpha 1 x e to the x. The next step is to operate g of d on yp and set it equal to j of x. Combine like terms and solve for the non-arbitrary constant. So d cubed minus d operated on yp gives us alpha 1 e to the x times x plus 3 minus alpha 1 e to the x times x plus 1 equals e to the x. We can cancel out e to the x and combine our like terms, which is pretty simple in this case because all of our unknowns are just alpha 1. We get alpha 1 times x minus x, which is 0, plus 3 minus 1, which leaves 2, equals 1. So 1 divided by 2 equals alpha 1. Alpha 1 is 1/2. The non-arbitrary constant in yp has been found, so the solution to the differential equation is yc plus yp. We have c1 plus c2 e to the x plus c3 e to the negative x plus 1/2 x e to the x.